Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, California Resources Corporation, Kern County Water Agency, Southern California Edison, Kern Schools Federal Credit Union, and Panama Buena Vista Union School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Chuck. Give us a call if you need help with your math. You can call here in Bakersfield at 636-4357. San Luis Obispo and the outlying areas, you can call toll free at 1-866-636-6284. You can email us questions at dothemath@kern.org. You can watch the show live online at dothemathonline.net. And look for us on social media. We're on Facebook and Instagram, Twitter, and YouTube.
And a lot of students are probably viewing the program more online.
Good, yes.
And one reason for that is that even if you're not at home, you're able to view it online pretty much anywhere.
Right,
as long as
and
you have
if
some
you
sort of
don't have
device.
cable, you can watch it online. If you have, satellite or dish, you can.
Right.
Yeah.
So a couple of things before we get going with our guest of the afternoon. First of all, if you do call from San Luis Obispo County, we do your math problem on air. You will automatically win yourself some ice cream courtesy of our friends at Doc Bernstein's Ice Cream Lab. And all of the students that phone in today, we do their math problems. You automatically entered into a drawing for a 4-pack to go see the Bakersfield Condors. We do have a couple of very special guests in studio today, but before we get to all of that, let's first take a look at today's Math in the News. All right. You know how to read numbers.
Yes.
Can you give me an example of how you would read numbers? Like if I said 4
Like
is
a-
greater than 2, I'm
like-
reading a number sentence.
Right, or a phone number, or phone numbers. I'm reading numbers there. You recognize the number for what it is.
Right.
It's a number.
So you can, 20 million is equal to 20 million.
Right.
So there are a lot of different ways you can read numbers.
Okay, yes.
All right. So, you have not seen this, and we're going to put this up right now. So let's put this up on the screen, and I would like you to read that. I know I'm putting you on the spot right now, but let's go ahead and see. Go ahead and.
So the thing that starts with 7H15,
Right. So what I'd like you to do
Okay.
is see if you can read it, like you're reading a paragraph.
so I'm reading paragraphs. So if this is supposed to be a sentence, I guess that first thing must be this.
Correct.
Message serves to prove, so the 7 must be a T, prove how our minds can do amazing things, impressive things. In the beginning, it was hard, but now on this line, your mind is reading it.
Right.
Oh, wow,
So see,
okay.
so it
Right.
took a second, right?
Yeah, it took a while to
So I
realize
found an
what was going
article.
on.
So while you're reading, you don't pay attention to the difference between a number and a letter because you only expect letters.
Right.
As people read the message, they're able to decode the oddly shaped letters in a matter of milliseconds because the human brain essentially treats them like numbers written by someone with bad handwriting or an unusual typeface.
Right. For
For your brain, it's not a number in a word, it's a wrongly written or strangely written letter. So
Okay.
that's how your brain is seeing it, this, according to these guys. You're in this mode of tolerance that allows for small distortions in the identity of the letters.
Right.
The phenomenon is nothing new.
Really?
No. They say in the early days of the internet are well familiar with leet speak. 1337. So the 1 would be an L, the 3s are E's, and the 7 is a T, as you just pointed out. Leet speak, an alternative alphabet used by online communities to evade detection by search engines. Although there may be some truth to the idea that some people are more adept at reading leet speak than others, Young people who have grown up using computers with an endless typographical choices may find it second nature to look at that paragraph and read it a little bit quicker.
Right.
On the other hand, an older person, as ourselves,
Yeah.
likely raised understanding standardized cursive, would find deciphering it a little bit tougher.
Okay, maybe a few seconds longer.
And I
We
you know,
got through that.
tried that because I had people of different ages read it. And people our age, right, it's like, all right, this, you know, it's like,
Yes.
all right, now I got what they're doing here.
Right.
And it flows a little easier
Right.
after that.
And by the time we got to the bottom, it
But
was
younger students, it was this message serves, you know,
right.
just go right along with it. So just another way to read numbers in a way that you wouldn't expect to.
Right.
And that is today's Math in the News. 636-4357 is the phone number. We do have phone tutors available until 5:30 on most Tuesdays and Wednesdays throughout the regular school year. A reminder, we have a 5th grade call-in contest going on right now. So all during this month, this is day 4 of 8, I believe. So
Good.
we're right in the middle of the 5th grade call-in contest. The 5th grade class that calls in the most will have an opportunity for Do the Math. We'll come out to your classroom, we'll award some great prizes, and you guys will be the feature class on a future episode of Do the Math during this season. Right now, we'll go to the phones. A student from Reagan. Ryan, how are you today?
Good.
And what grade are you in?
4th.
All right, as soon as you're ready, Ryan, let's hear the math problem that you're working on.
Okay. A carpenter has several boards of equal length. He cuts 3/5 of each board. After cutting the boards, the carpenter notices that he has enough pieces left over to make up the same length as 4 original boards. How many boards did the carpenter start with?
Okay, so he has boards and they're all of equal length, right?
Yeah.
And he's going to cut 3/4 of each board. So he has a board right here. And he's going to cut 3/5. So let's just look at a picture of what this is. 3/5 means there are 5 pieces, 5 sections, right? So if I do 1, 2, 3, so there's 1, 2, 3, 4, 5, and he's going to cut 3/5 of this, right? So he's going to do 1, 2, 3/5 right about there, and this is how much he's going to cut, right? So he's going to cut 3/5 and he's got 2/5 left over. So he's going to, let me go back and figure out what the problem is saying. He's going to cut 3/5 of each board, and what's left over is what he's going to use
Yeah, to make 4 more boards.
to make 4 more boards. So he's going to take this and okay, go ahead and read the whole problem. So now that I see what they're doing, what are they asking for? Go ahead and read the whole. Okay, go ahead.
A carpenter has several boards of equal length. He cuts 3/5 of each board. After cutting the boards, the carpenter notices he has enough pieces left over to make up the same length as 4 original boards. How many boards did the carpenter start with?
Okay, so if he's gonna take these pieces, right? So he's got these pieces right here, and he's gonna cut this 3/5 off, right? And he's gonna end up with 2/5, and he's gonna put the 2/5 over here, right? And he's got enough of these small pieces to make 4 boards over here, right?
Yeah.
So here's the question. These are each 2 pieces, 2/5, right? That's 2/5, and this
Yeah.
is 3/5. This is 2/5, and this is 3/5. How many of these fifths does he need to make 4 boards? Well, let's look. If he's got 1 board, that's 1, 2, 3, 4. 1, 2, 3, 4, 5, right?
Yes.
How many of these fifths is he going to need?
1.
Okay, so 4 boards, right, is how many fifths? You think you can figure this one out? If he has 4 whole boards and he's taking these fifths of a board, right? How many fifths are there in 4? Okay, Ryan, so here's the question. What number divided by 5 equals 4? figure that out? What number divided by 5 gives me 4? So here's a hint. If I wanted to change this fraction 4/1 into something over 5, remember have you worked with fractions?
Yes.
If we multiply the bottom by 5, 1 times 5 is 5, isn't it? But have you reduced fractions? Have you worked with reducing fractions? So if I multiply the top by 5, isn't 4 times 5 equal to 20?
Yes.
So what's 20 divided by 5?
4.
There's your 4, isn't it? So I know to make 4 boards over here, and let's see if I can fit 4 boards over here. Here's one more, and here's some skinny boards down here at the bottom, right? They've all got to have 5/5, don't they?
Yes.
So to make 4 boards, I'm going to need 20 of these fifths, aren't I?
Yes.
So here's 2/5, right? And here's 2 more fifths, but I need 20 of these, don't I? So how many of these little pieces are we going to need to make 20/5?
5.
Well, let's see. If I have 2/5, and if I take 5 of them, that's going to give me 10/5, isn't it? And 10 divided by 5 is only 2, isn't it? So five of these pieces, 5 of these boards would give me 2, but I need 4. So 5's not enough. I need
10.
let's see, what happens if I have 10 of these boards and I have 10 of these pieces left over, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If I take 10 of them, that's going to give me 20/5, isn't it? And that 20/5 is what's going to give me my whole number 4, isn't it? So I'm not sure how they wanted you to work this out with the fractions, but if I just look at the pictures, you see this? 2/5 times 10 gives me 20/5, and so it looks like it's going to take 10 boards to do this problem. Okay?
That help you out, Ryan?
There's your answer that you
Yes.
gave me right down there.
All right.
That was
Well,
the 10.
as long as we still have you online, let me know that because that was such a wonderful problem, we're going to send you home with a meal courtesy of our friends at Johnny Rockets. So congratulations on that. We do have phone tutors available until 5:30. I thought that came out a little weird when I was saying it. Anyway, in studio with us now, we'll go to somebody that can get it out a little easier. Dr. Charles Lamb, how are you?
Nice to meet you.
You are with Cal State University, Bakersfield.
Correct.
And yesterday we had another person from Cal State University, Bakersfield, Dr. Lefevre, in the chemistry department.
Oh,
You're
okay.
aware of this young man?
Yes.
Okay, I'm only kidding. I know you guys. Okay. And what is your title at the university?
I'm the professor of mathematics at CSU Bakersfield, and I'm also the associate chair of the mathematics department.
So if somebody wants something done in mathematics, they're going through you.
They're going through me or through the chair, Dr. Sophia Rashkovsky.
Okay. But they'll go through you first.
Sometimes,
Right,
yes.
you take care of things first, and if need to, then they go up to the other one, right?
Yeah, that's correct.
All right. How long have you been with the university?
It's been 12 years.
All right, so 12 years, everything's going well.
Pretty good.
Somebody wants to go to CSUB and they're not sure, but they're going to be taking some mathematics and they kind of like want to test it out. What kinds of things can they look forward to at the university?
Well, if you want to be a mathematics major or a science major, then it's very likely that a student will start with either pre-calculus or calculus.
Okay.
And
And what should they be looking for as they're in high school to prepare them for that? Because obviously not everybody's going to come in ready for
that is true.
pre-calculus.
That is very true. And my suggestion is that you take the full 4 years of mathematics courses.
That's exactly what I was hoping you were going to say.
Yes. And you should take the regular path of mathematics that goes from Algebra 1, Algebra 2, Geometry, and then likely math analysis. If you're not there yet, this is totally fine. As long as you finish Algebra 2, then we can take care of you from there.
Okay. And what are some of the activities that you guys have going on at the university that math students can be involved in?
As a math major, we have a very comprehensive department. We have faculty that are in various areas of mathematics, in statistics, in applied mathematics, or for myself, my research area is in cryptography. And so a lot of the students who are interested in pursuing something other than just taking a mathematics course, they can also conduct research with our faculty members as well. Or we can guide them with some independent studies courses that they can read up on materials that are not normally offered as a regular course.
Okay, and the way I met you was a couple years ago through the Revs Up program at
Correct.
CSUB, and the unit that you guys were working on had part of it with the cryptography.
Yes.
And that's what I found interesting. So can you talk a little bit about what you've done with that at the university?
Well, cryptography is the study of communication security. What we do is to try to turn a message into something that people can understand so that it protects the privacy of the message. And so in the Revs Up program, what I did with the high school students is that we learned the mathematics behind this. Cryptography was an art that started about 2,000 years ago. It was about hiding the message during war times, basically, to convey secret messages between the central command and the front lines. And as time goes by, human intelligence improved, and so what we developed in the past is no longer useful now. And in the past 30 to 40 years, we have a significant improvement in hiding messages, in the art of hiding messages. And the modern day cryptography is basically all based on the study of an area called number theory, which is the study of integers and how we turn the message from integers and then turn these numbers into, well, we transform it into another set of numbers and turn it back to English characters. And this is how we encrypt messages today. And the study in the past 40 years is basically, the direction is that all the encryption is based on numbers.
Okay, and that's what I found fascinating. You know, and as you said, this has been going on for a couple hundred years during wartime, especially, because I know there are some students and adults that are probably familiar with some recent movies dealing with that topic, but
Yes.
goes all the way back pre-revolutionary time.
Yes,
In the United
the
States.
first ever documented cipher is actually from Julius Caesar.
Okay.
And we called it the Caesar cipher. What it did was just to shift characters by a few spaces.
Right, so instead of, all right, so I'll put, instead of A, I'll put D, so I know I'm moving 3 spaces, and as long as you know that
Yes.
that's what you're doing, you can look at it and figure it out pretty easily.
Right.
But you have to start somewhere.
Yes. And back then, most of the people were illiterate, so that cipher was secure because of that. As more and more people know how to read, then it becomes insecure, and we have to find different ways
All
to
right.
make it more difficult.
Well, you know what, if you got a couple of minutes to hang around with us,
Sure.
all right, we'll hang on right there. 636-4357 is the phone number. Right now, we'll go back to the phones. A student from Singlum. Chanel, how are you today?
Hi, I'm good.
And what grade are you in?
I am in 4th grade.
All right, 4th grade day today, it looks
All
like.
right.
Let's go. I bet you it's going to have something to do with fractions, possibly. Chanel, as soon as you're ready, let's hear that math problem.
Okay, so it says, Tim has 12 black and white photos and 18 color photos. He wants to put the photos in equal rows. So each row has either black and white photos only or color photos only. In how many rows can Sam arrange the photos?
So you want to put them in rows so that you have the same number of black and white and the same number of color photos in each row. Is that it?
Yes.
Maybe read it one more time all the way through so that we make sure we have all the information.
Yeah, I wanted to get the numbers first.
Okay, so it says Sam has 12 black and white photos and 18 color photos. He wants to put the photos in equal rows. So each row has either black and white photos only or color photos only. In how many rows can Sam arrange the photos?
Okay, so we're going to put these in rows, and we want the same number of photos in each row, and they're either all black and white or all color. Is that right?
Right.
So what is it that we're trying to use here to do this with that 12 and the 18? Do you know what it is that we're trying to find if we're going to make these rows? I mean, I can't make, you know, a row of 12 black and white and 18 color because they'd be different lengths, right?
Yes.
So what could I do? How long could I make it if I wanted? Do you want to know the least number of rows, did it say, or the most, or just how many rows?
Well, I needed to know that how many either black or white photos or only color photos in equal rows. He wants to put in the equal rows.
Okay. So if these rows are all, so here's my row of photos. I don't know how many are in this row, correct?
Mm-hmm.
Okay. And that's either going to be all black and white or all color. And then I'm going to have more photos down here, but it's got to be the same number, right? And I don't know how long the rows are going to be. So again, I'm trying to figure out, they want to know how many photos in each or how many rows?
How many photos in each row?
Okay. So let's see if we can divide these up into a length of photos, a length of a row, so that they're equal. Okay? So
Okay.
can you tell me what, if I was going to divide this up into a group of photos, can you tell me what number can I divide these up in that is the same for both 12 and 18? So
You can divide them into 6.
yeah, so both of those numbers can be divided by 6, can't they?
Yes.
So I know that 12 divided by 6, that's 2, so I could get 2 rows of black and white, and 18 divided by 6 is 3. So let's see, 1, 2, 3, 4, 5, 6. Well, there's 6. So I could do black and, let me write black and white here. So I could do 6 black and white photos and 6 more, right? If 6 is my common number, right?
Right.
Have you been working with greatest common factor and least common multiples? Have you been working with those in class?
Yes.
Yes. So you know what this 6 is? It's a divisor, but it's also a factor, isn't it? So this is
Yes.
the biggest number that will divide into 12 and will divide into 18. So have you worked with the term greatest common factor? Have you worked with those? So if I draw a picture of this, then I like drawing pictures so I can see this. There's my 12 black and white photos, right?
Right.
So there's 6 and 6, so there's my 2 rows of 12, right? Or excuse me, 2 rows of 6 to give me 12. And then I can do the same thing with color. I'll put a C in here for color. There's 1 row of 6, there's 2 rows of 6, and there's, looks like 3 rows of 6.
Now you could be thankful the numbers weren't 120 and
I
180
sure am.
number of photos. So, but the same concept will work here with finding that common
So
factor.
it looks like if I took 12 and 18 and looked for that common divisor, that number that'll divide into both of them, we could get 6 photos in each row, right? And make 12 black and white photos and 18 color photos. Okay? Is that going to be the answer? Was there just one answer? Because we could do it with fewer, but that's the least we could do it with. Okay? So it looks like
Okay.
it's going to be 6 photographs in each row.
So Chanel, before we let you go, that's what I wanted to bring up is that's one way to do it.
Yes.
But Chanel, is it possible to cut that 6 in half and put 3 in each of the rows? So take a look at the graphic again, and are you able to go from 6 to 3? Can that still be equal all the way through?
So we could get and do 3 of each of those photographs in each row and still get an equal number, couldn't we?
Yes.
That's why I just wanted to make sure that she understood
Okay.
that you could still do it another way,
Yes.
aside from having 6 as the factor right there.
All right.
Well, Chanel, since that was such a great problem and you made Chuck do a lot of drawing of
Thank
squares
you.
on there, we're going to send you to the Maya Theaters so you'll be able to go and check out a movie. Congratulations on that. We do have phone tutors available until 5:30. In studio with us right now, Charles Lamb, professor at CSUB. Talk a little bit about some of the research that your students are doing at the university.
Okay, so for myself, my research areas in cryptography and communication security and digital watermarking. In the past, some of my students have been doing a project on digital watermarking with me. Digital watermarking is an area that has to do with digital rights management. So say, for example, there is a lot of piracy happening. People would download movies and they share with other people, and we know it's illegal.
But we don't have to imagine it. There is a lot.
Yes, there is a lot. And basically, this is costing studios and music industry a lot of money. And what we do is to try to prevent people from stealing.
Okay.
So what we do is injecting some signals into the movies, into songs, so that when people try to share it with other people, try to steal it, then they can be identified.
Okay. Would they be identified by stealing it in the first place?
The person who's...
Or do they have to try to disperse it from there?
Okay, if they disperse from there, then they're distributing the wrong thing. So if you download it for your own use, well, it's not right, but we're not catching people doing this.
Okay,
we're catching people who try to distribute it without the permission.
Gotcha.
And what I do with my students is that we're actually trying to be the hacker side. So we want to try to see if the proposed algorithms, the proposed way of embedding these secret signals into the movies or into music is actually good enough. And so we try to find ways to try to break it and to see if we can break it. And what we have done so far is that we are able to reduce the signal by about 40%. So remove some of the signals.
All right, so that's working well. Now, before we let you go, you have another duty at the university.
Yes.
And briefly tell us a little bit about that, if you don't mind.
I actually coordinate the assessment efforts for the School of Natural Sciences, Mathematics and Engineering. The assessment is basically a mechanism to show to the rest of the community that the students coming out from our university actually learns what they're supposed to learn.
And how much time does that take from you?
It takes quite a bit of coordination with faculty and to make sure that everything is well documented so that we can present to our corresponding accreditation agency that we are actually doing the effort.
Doing what you're supposed to and what you say you're supposed to be doing and things like that. And kids come out ready to move on with whatever career they're ready to go.
Exactly.
Right.
And so far we've been doing a pretty good job according to the accreditation agency.
All right, well, you know what? We know you're certainly a busy man. We certainly do appreciate you taking out some time to come visit us here.
Thank you.
636-4357 is the phone number. Phone tutors are here until 5:30. We'll be back with more and our next guest right after this. Well, today we're in Shafter. We're at Sequoia Elementary School, and today we're here to... Well, today we're at Sequoia Elementary School, and with me right now I've got Philip, a fifth grader, and we're going to work on some percents and fractions, okay? So, have you ever taken a test?
Yes.
Yes. And what is the highest you can get on a test?
100%.
100%, right? Have you gotten 100% on every test you've ever taken?
No.
No. So you've probably gotten a very high score, though, I'm sure,
Yes.
right? So what's an example of one of your high scores?
Like 95%.
Like a 95%? Why don't you go ahead and rate 95% up over there? Now that 95% means you got a 95 out of what?
100.
Out of 100. Are you familiar with fractions at all?
Yes.
Okay, so how would you write 95 out of 100? Perfect. So what we're doing is we're going to write this 65% as a fraction. You wrote one of your high scores, 95, as a fraction. And we can simplify that, but what we're going to do is we're going to simplify and do the problem right here, the 65%. So how do we write 65% as a fraction?
You put 65 over 100.
Perfect. Go ahead and do that. Now that technically is the answer. You wrote that as a fraction. Pretty simple problem, isn't it?
Yeah.
Nicely done. But not so fast, young man. We're going to simplify this now. You know how to
Okay.
simplify fractions?
No.
Okay, that's exactly what I wanted us to do. So you're going to think of a number that goes into 65 and 100. What number can you think of goes into 65 and 100?
5.
5. So here's what we're going to do. Let's divide each of these by 5. Okay? I'm going to do one and you do the other one. So I'm going to do this. 100
Okay.
divided by 5 is 20. I did the harder one.
Okay.
All right, so you do 65 divided by 5.
Okay.
And if you need to write it off on the side,
Okay.
you go ahead and do that. So how many times?
13.
Okay. Now, we simplified 65 over 100 to 13 over 20, 13 twentieths. Is there any number that you can think of, other than 1, that will go into 13 and 20?
No.
No, there isn't anyone, right? Because 13 is a prime number, right? Only 1 and 13 go into it, and 13 doesn't go evenly into 20. So now, Philip, we're finally done. Good work. Today we're at Sequoia Elementary School, and I've got 6th grade student Natalie. How are you today?
Good.
You ready to roll?
Yes.
All right. You've got a lot of stuff going on up here. Why don't you go ahead and tell us what we have to do?
Okay, so we are going to be evaluating the expression.
Right, so we're going to evaluate the expression. Why don't you go ahead and read the expression first of all?
Okay. 2 plus 28 divided by 2 square.
What about this?
Oh, 9
Yeah.
times.
There you go. So we can't forget about this 9 times. And I put that in there because a lot of times you know, I'm sure as a 6th grader, that if you just have the 9 out there, it means to multiply, right?
Right.
And there's a lot of different ways to represent multiplication. You could do it like this. But also just that dot is the same thing, right? So I just wanted to put that up there for some other students. So we have to evaluate this expression, and there are a variety of ways we could do this, but there's only one correct way. How should we start?
Okay, we should start with the numbers inside the parentheses.
Okay. So go ahead and
So-
grab the marker. And so if we're not going to do anything with the 9, what should we do with it?
We should,
Maybe we can just bring it
yeah,
down?
bring it down.
Okay. And let's open up the parentheses.
Okay. So,
Now, before you go ahead and start, are you familiar with the order of operations? Where you do parentheses first?
oh yes,
After parentheses, then what?
it's exponents.
Exponents. And then,
It's multiplication.
and then,
And then division.
so multiplication, division kind of go together, and then what?
And then addition and subtraction.
Perfect. So parentheses and then exponents.
Right.
So we have parentheses, and we're going to do everything in the parentheses, but first we have to take care of what?
The exponent.
The exponent.
So we're gonna do 2 times 2 times 2, and that equals 8.
Well,
So
what's 2 times 2?
4.
Right.
Oh, okay. So
Because you said 2 times 2, and then you said 8, because I think you were saying 2 times 2 times 2. So 2 times 2 is 4. So 2 squared is 4. So let's go ahead, open a parenthesis right here for me. So the 2, we're not doing anything with right now.
Right.
So we'll just bring that down. The plus 28, we haven't done anything with that.
right. And
The
then
division symbol,
And then the 2 square becomes a 4.
Perfect.
So we're gonna bring it down and put a 4.
and then close that parentheses. Perfect. Because a lot of times students will go 2 plus 28 first, and they'll write 30. and then it'll get all messed up, right? So now, we still have our parentheses that we're going to multiply everything by
Right.
9. But inside here, what do we have to do first?
We have to do the division.
Perfect. And what division do we need to do?
We have to do 28 divided by 4,
Very good.
which equals 7.
Good. So how do we write everything down?
So then we make another parentheses and we put a 2 plus 7.
There we go. It's just easy to remember to keep bringing it down. Otherwise,
Yeah.
we might just forget about it. Now what?
So now we get to do the addition. So we do 7 plus 2 is 9.
Okay.
And then we have the 9 outside the parentheses again. And then now we can multiply those two.
Okay.
So 9 times 9 equals 81.
All right. So go ahead and write that final answer. Natalie, perfectly done. Nice work.
Thank you.
And once again, a big thank you to everybody at Sequoia Elementary School. In studio with us right now, Azul. How are you today?
I'm good. How are you?
I'm wonderful myself. Why don't you let everybody know where you go to school and what grade you're in?
I go to Maple School and I'm in 8th grade.
Now, Maple School, a lot of people may not be familiar with that because it's not right in Bakersfield. Where is that?
It's in Shafter. It's out in the country. And it's kindergarten through 8th grade.
So it's a K-8 school.
Yes.
And you've been there for a couple of years.
Just 2.
But you're ready for junior high.
Yeah.
Or, right, high school.
yeah,
junior
yeah.
high. So what has been the best thing about your 8th grade year so far?
Just, I guess, my friends, getting closer to them.
Okay.
And, you know.
Because you've only been there a couple of years, right?
Right,
So
yeah.
you're getting to know your friends a little bit.
Uh-huh.
And what do you look forward to the most as you enter high school?
Just getting the experience, you know, of high school and, you know, just kind of like getting the experience of high school and learning a lot.
Okay. Well, if you remember when Charles was on from CSUB talking about, well, do Algebra 1, Algebra 2,
Yeah, he said
go
all
through that
4,
kind of
yeah.
stuff. So you're into doing all 4 years
Yeah,
of
definitely.
excellent. That's exactly what we wanted to hear. So what we're going to do now is we're going to put you to work.
Okay.
All right, so let's take a look at the problem that you'll be working on. This one says, Big Mac's tea shop has caffeinated tea and decaffeinated tea. The tea shop served 6 caffeinated and 14 decaffeinated teas. What percentage of the teas served were caffeinated? Write your answer using a % sign. So if you would go over to the board and you can explain to us how you would attack this problem and solve this problem. If you need any assistance, we've got a young man right over there to help you out.
Okay, thank
All
you.
right?
Okay, so can you put the problem back up?
So we've got 6 caffeinated,
Okay.
6 caffeinated and 14.
so maybe just 6C so we know the caffeinated, and then 14 decaffeinated.
So the question is,
The
what
percentage of
the tea?
teas served were caffeinated. What % were caffeinated?
Were?
Yeah.
Right, so how many were caffeinated as a %?
Okay.
So how would you set this up?
Would you add these and then?
So if you add those together, that's going to give you the total number of teas, right? So how many
Yeah.
total teas are there if you add those together? Just the 6 plus 14, right?
Right.
Add them up. What do you get?
22, right?
Hmm?
Is it 22?
No, 6 and 4?
10, 11.
Well, let's see.
Wait,
we got
no.
4. Yeah.
Sorry.
Okay, there you go. So we've got what's 6 plus 14, right? That's all we're doing. Just add those together. So what's the total number?
Is it 20?
20. So we got 20 teas altogether, right? Of those 20, how many are caffeinated?
14.
Well, there's a decaffeinated. That's the D. So I think they wanted the percentage of caffeinated.
How many
so we
are
got
caffeinated?
6, right?
6.
So we want to compare these two numbers. So we're going to compare the number of caffeinated to the total number. So we're going to write that comparison as a fraction.
Okay,
So let's write that as 6 out of 20. Or 6 over 20. If you want to move this down, we can move this down and just put 6 over 20, let's write a fraction over here.
Okay.
And just write 6 over 20. So what this represents is 6 caffeinated out of
Out of
a
20.
total of 20.
Yes.
So here's the question. Can you change that fraction to a percent?
Yes, you would divide these two, right?
Okay, so let's divide those, and that's going to give you what? A decimal, right?
Yes.
So let's divide that out. What do you get? What do you divide? What happens when you divide 20 into 6? Maybe you can do that right over there. Divide 20 into 6, right?
That.
Mm-hmm.
And then you
Since you can't do that, what do you have to do?
you add a 0.
Right, you got to add a decimal and some zeros, right?
And then you can't. Oh, yes, you can. You do 4.
Let's see, 20 goes into 6 how many times? Or 2 goes into 6 how many times?
4.
2 times.
3.
So 3. So 2 times 3 is 6, right? So you're going to have 3. And they go in there evenly?
Yes.
3 times 20 is 60, right? Okay, so now the question is, where does that decimal point go now up here? It's going to go straight up, isn't it? And so that 3 is over the 0. So we'll put that decimal straight up in front of the 3.
Okay.
Okay, so you know that 6/20 is
0.3.
0.3. So go ahead and write that down. So you said, let's change it to a decimal.
Right.
Now, how do you change that decimal to a percent?
You would just do. What? Would it be 100 or?
Well,
no,
we
let me-
know that that's 3 over 10, right?
Uh-huh.
But do you want to change this? Just let's go from a decimal to a percent. You remember how to do that from a decimal to a percent?
I know.
There's 2 ways we could do that. What you just were doing, instead of changing to a decimal, you just reduced 6/20. You could write that as the whole number 3 over 10, couldn't you?
Right.
So let's get rid of the decimal, and then let's write that decimal as a fraction. Let's write that as 3 over 10. It's still a comparison of 2 numbers, right? But percent's based on 100, isn't it?
Right.
So we want to change this fraction so that there's 100 on the bottom. So let's write that equals to another fraction.
To what?
Now, let's see, we want a fraction with 100 on the bottom. So make a fraction and put 100 on the bottom. What's got to go up on top?
20.
3 over 10 equals what over 100?
Oh,
So what's going to go there?
a 3, right?
Well, 3 over 10, but
Uh-huh.
what over 100? So what do we have to do to 10 to get 100? Don't we have to multiply by 10?
Yes.
So if we multiply this by 10, we get 100. If we multiply this by 10, we get
30.
30. So that's going to be 30 over 100, isn't it? And what's 30 out of 100 as a percent?
30%.
30%. So our answer down here would be
30%.
30%. So in this case, it was pretty easy to do it as a fraction
Right.
and not have to worry about decimal. So it looks
All
like
right.
our answer should be 30%.
There you go. Nicely done. Why don't you erase that board? Chuck
Sure,
has
I'll
an
erase-
easy
I've
way
got it
there
right
as
here.
well instead of.
Erases the whole thing.
There you
Okay.
go. All right, stay to the board, and we're going to have you do another problem right now.
Okay.
All right? Start all the way over on the left.
Start here.
Okay.
So we're going to start with -3. Open a set of parentheses. Inside the parentheses, you're going to put 1 over 6, 1/6. Outside the parentheses, you're going to put another set of parentheses and put a 2 in it. Close the parentheses, and now put divided by 1/4. And we'll have you guys work on that one.
Okay.
Okay, so let's see. What do we do in a problem like this? Remember our
You
order of operations?
You always do the things in percent.
Parentheses
yes.
first, right? So in the parentheses, we just have a 1/6. There's really nothing to do here or here. So it turns out that in this case, these parentheses just mean, what am I going to do with these numbers?
Right.
What operation are we going to use?
We're gonna.
So we know that this parentheses means multiply here and multiply here. So we might put a dot here and a dot there, so we know we're going to multiply, right?
With
And
here.
there, right. Right? So this is multiplication, this is multiplication, that's division. Let's go ahead and do the multiplication and we'll leave the division for last, okay?
Okay.
So let's go ahead and multiply the first two. What's -3 times 1/6? Well, we know that -3 as a whole number, or 3 as a whole number, is 3 over 1, isn't it?
Yes.
So go ahead and write that as a fraction, 3 over 1. Okay? Times 1 over 6. Let's go ahead and do that. What's What do we get for that?
Just
Yeah, on top it's just -3 times 1, right? And on the bottom,
6.
6. And, okay. Now what?
And then you do that times 2.
Let's multiply that times 2. And we know that's going to be 2 over 1, right?
Mm-hmm.
And what do you get when you do that?
-6 or?
-6 on top, right?
Okay. And then 6. Sorry. Okay.
Yeah, something should show up very nicely here, because what's -6 over 6?
-1.
Yeah, that's just -1, so let's write that as -1. So we've done these first 3 and we multiply them together. So what's left is dividing by 1/4, right?
Mhm.
What does it mean to divide by a fraction?
You divide just by the whole number that it equals.
Well,
So
if we divide by a fraction, what do we do when we divide by a fraction? We're going to multiply by, remember changing this to a multiplication problem?
right.
If I change this to multiplication, what do I have to do to that fraction?
You rotate it.
Yeah,
but
you have to flip it over.
Flip
We
it around.
use the reciprocal. So let's go ahead and multiply that times the reciprocal, which is 4 over 1.
4 over 1.
And what do we get?
-4.
-4 on top, 1 on the bottom, which just
Equals
leaves it.
-4.
So it looks like our answer, Mr. Krishan, should be -4.
There you go. Nicely done. 636-4357 is the phone number. We do have phone tutors available until 5:30. It is the 5th grade call-in contest going on this entire month. We're halfway through. We'll be back with more. We'll make Azul do some more work right after this. Well, the purpose of the field trip is for the students to see firsthand a lot of the planes that we've been talking about in class. Also being able to hear from experts the principles of flight.
The wind going over the wing creates lift.
When the kids are able to go and experience it, there are planes that they can actually touch, get into. They're hands-on activities that the kids can do to learn, all right, I know what yaw is, but if I do this, what is that going to do to the plane if you're controlling the stick? If you've got 1 foot on the rudder, which way is the plane going to turn now? So they can experience things like that.
And it's maybe a little more difficult to impart history to what they're looking at. But what I like to do is try to plant the seed of, you might consider this as a living. I don't know how many kids have that dream, but if you can help plant a seed, what does it hurt?
And I really like seeing the replica of the Wright biplane, the first plane to fly.
There are many air museums around the world. I don't know how many of them fly any planes, but she's the only flying P-26. She, of course, is the only flying Jack Northrop flying wing.
I saw this one-of-a-kind plane. They only have one of it in the world, and I thought that's cool that it could be here. You can just see it in a picture, but when you're actually there, you can see every little detail and examine every part, so you can see what actually makes the plane work.
They know what yaw is and where that is controlled. So when they look at the rudder, the tail of the plane, they know that that rudder controls yaw, and they know what yaw is, being able to make the plane turn. They also know that the ailerons are a part of that also, which helps with the plane and the roll.
Just seeing all the different styles, like how each one has like different sets of wings or different propellers.
Yeah, I was kind of surprised that they'd actually make a plane that would actually go on water with a boat. I just thought that was cool that they would make that.
And everybody that comes here and then has that realization that many of our airplanes fly, there's a different perspective I think they have. There's a plane over there that was in my uncle's fighter unit. Unfortunately, he did not survive Korea. Stuff like that. So for me, it's a huge emotional event. Just to be here and take people through, this is the most fun I've ever had, and the most rewarding thing I've ever done.
There's just an enormous amount of things for the kids to look at and learn this afternoon. So this is kind of the midpoint right now. So then what they'll be doing after this is taking wings, different types of wings, and testing them based on what they've learned here so far. The Planes of Fame in Chino is an excellent air museum. The kids have just had a great time with it all day and probably look forward to coming back to an air show. And once again, we have Azul in studio with us, an 8th grade student from Shafter and Maple School is the school, correct? Mm-hmm. All right. We're going to have you do one more math problem. Okay. But before you do that, I'd like to ask, the phone call that was in the tutor room was a calculus problem from Arizona.
Yes.
Are you cool if somebody from Arizona called with a calculus problem to help them out?
Sure, yeah.
Why not? Give it a try, right?
Yeah.
Well, we won't put you on the spot like that. We'll just have you do a different type of problem right now, all right?
All right.
So back to the board with you, please.
Go ahead.
We're going to buy a bunch of different items, and then we want to figure out what the total cost is, all right? So we're going to buy 3 ties at $19.95 a piece.
3.
So 3 ties at $19.95 a piece. Next, we're going to buy a belt. One belt for $23.50.
$23.50.
We're going to buy some boots, just one pair.
Boots.
And the price on those are $124.95. And once we purchase all of that, we will need to add 5% tax.
Okay.
All right, so how would you like to start?
Well, you would multiply 3 times 19.95.
Okay, so let's see how much those ties cost. Let's go ahead and do the multiplication.
Hold on, before you do that, I'd like you to do this in your head.
Okay,
Think about 3 times 20.
Okay.
so if they were $20 each, how much would 3 ties cost?
60.
$60, right? So that would be $60 if they were $20. But they're not quite $20, are they?
5 cents back.
5 cents back. So 5 cents back for each tie. How much is that?
It would be
Fif-
59.85.
It would be 15 cents,
Right, so
right?
you got it, $59.85.
$59.85 because it's 15 cents less. So that's going to be $59.85. That's much easier, wasn't it?
Right.
55.
Okay, now we're going to add to that 1 belt and 1 pair of boots. So let's just add these up. $59.85 plus $23.50 plus that really fancy pair of boots for $124.95.
Well, what about the belt for $23.50? I don't think I'd ever buy a belt for $23.50 and
Okay,
have
so
a meal attached
let's
to
add
that.
those up. Let's see.
Okay.
Let's give us some more room down here. So let's just add them up right here. And let's just do it right here under the $59.85. Let's put the $23.50 and the $124.95.
Oh, we should add this first.
Okay.
It's 13.
Mm-hmm.
And then,
Probably just put that right underneath
So
the
now-
124.
So now here's the 8335, and we're going to do it with the 124.95, right? Just got to make sure you get it nice and lined up.
10. 13. And then it was
So it looks like the total is $208.30, right?
You are correct so far.
Now, we need this, and we said this was going to be 5%, right?
Oh, yes.
So 5%. And how do you write 5% as a decimal?
0.5, right?
0.05, because we're going to move that decimal point 2 places, aren't we? We're going to move it 1,
Right.
2 places. So let's go ahead and multiply that times, we're going to multiply that times
Oh.
0.05. So let's go ahead and do another multiplication. And right below that, let's just go put the 0.05 there.
We're going to multiply.
Multiply 208.30 times 0.05.
And for the sake of time, I'll let you know what that will come out to be. That will come out to be 10.415.
4.
And now you'll need to round that because we're dealing with money.
Since we're dealing with money, we can only have 2 decimal places, right? So how much money is that?
That is.
That's $10, right?
$10, yes.
But how many cents is that? We can't have 415 cents, can we?
No. So,
So this would be 41 cents, wouldn't it? But what's that 5 going to do?
are you going to add it?
Yeah, we're going to round up, aren't we? So instead of 41 cents, it's going to be $10 and?
50 cents.
Nope, add
Nope.
just a penny.
Okay.
42 cents.
42 cents.
So write that down, $10.42. But you want the total price, don't you?
Correct.
So this is how much all of this costs, and this is the tax, right? So what are you going to pay for it? You're going to take both of these and put them together. So let's go ahead and do that over here.
Okay.
Make some room over here. I think I can. Oops. Let's see if I can just erase this. Interesting. So move it to one erase. Okay. So let's see if we can. It's still one erase.
Well, maybe just move it down again and
Yeah. Let's just do it down here.
Okay.
So let's
and
take
you've
the
got 20 seconds to add it.
208.30. So write the 208.30 plus the $10.42. Make sure you line up the decimal points, right? And let's see what we get. And it looks like it's going to be $218.72.
All right, nicely done. Come on over, Azul. We're going to figure out who's going to see the Condors. We'll let you choose out of the phone callers from today. Go ahead and put your hand in there and grab one out.
Okay.
And who is that? That's Ryan from Ronald Reagan Elementary. So congratulations. Remember, 5th grade contest going on all this month. Phone tutors are here until 5:30. Until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, California Resources Corporation, Kern County Water Agency, Southern California Edison, Kern Schools Federal Credit Union, and Panama Buena Vista Union School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.